In section 5.5, we talk about systems of inequalities. So we have seen that equations in the form ax plus by equals c are straight lines when graphed. If we change the symbol equal sign to greater than, less than, greater than or equal to, or less than or equal to, we obtain a linear inequality in two variables. A solution of an inequality in two variables, x and y, is an ordered pair of real numbers with the following property. When the x-coordinate is substituted for x and the y-coordinate is substituted for y in the inequality, we obtain a true statement. The graph of an inequality in two variables is the set of all points whose coordinates satisfy the inequality. So to graph a linear inequality in two variables, we replace the inequality symbol with an equal sign and graph the corresponding linear equation. Draw a solid line if the original inequality contains a less than or equal to or a greater than or equal to symbol. And draw a dashed line if the original inequality has a less than or greater than symbol. You can choose a test point from one of the half planes. Do not choose a point on the line. Substitute the coordinates of the test point into the inequality, and if a true statement results, you shade that half plane containing the test point. If a false statement results, you'll shade the opposite side. So 2x minus 3y is greater than or equal to 6. So I'm going to go ahead and put this into slope-intercept form. And so I like to do it a little different than the book likes to teach it. So we use slope-intercept all the time, so why not continue using it? So we're going to solve for y. We have negative 3y is greater than or equal to negative 2x plus 6. Divide by negative 3. And we get y is now less than or equal to. Whenever we multiply or divide by a negative number, you flip the sign. And so we end up getting y is less than or equal to 2 over 3x minus 2. And so that means that my y-intercept is 0, negative 2, and my slope is 2/3, which means we can go up 2 and over to the right 3, or we can go down 2 and to the left 3. Because this is less than or equal to, this is going to be a solid line. And if you put it into slope-intercept form, there's a little shortcut you can use. If it's less than or equal to, so y is less than or equal to mx plus b, you shade below. If y is greater than or equal to mx plus b, you shade above. The y has to be on the left-hand side for this to work, and it has to be in slope-intercept form. Same rule goes for y is less than or y is greater than. And so using this shortcut, because y is less than or equal to, we will shade below. So let's go ahead and go to 0, negative 2. And then our slope was 2/3, so we can go up 2 units and over 3. Or we can go down 2 units and to the left 3. We have a solid line, and then we shade below. So anything that is below my line is a solution to my inequality. So go ahead and pause the video and try example number 2 on your own. So this one is already in slope-intercept form. So my y-intercept is going to be at 0, 0. My slope is -2/3. So we can go down 2 and to the right 3. Or we can go up 2 and to the left 3. This is greater than, so this is a dotted line. And because it's greater than, we're going to shade above. So go to our y-intercept at the origin. We're going to go down 2 units and to the right 3. And then go up 2 and to the left 3. This is a dotted line. And we will be shading above. And so this is the concept that I like to use, the graphing linear inequalities without using test points. So linear inequality must be in slope-intercept form to determine from the presence of a less than or greater than symbol whether to shade lower or upper half plane. And so we already did this. So for the vertical line x equals a, if x is greater than a, we will shade to the right of our vertical line, and if it's less than a, we will shade to the left. For horizontal lines, if y is greater than b, we'll shade above our horizontal line, and if y is less than b, we shade below. So we need to graph the inequality. Y is less than or equal to -3. So let's go ahead and do this in pink. This is a horizontal line. And we will be shading below. This is also solid. So let's go down to -3. We've got a solid line. And then we will be shading above. And so that's the solution for that one. And let's go ahead and do the second one in orange. This is a vertical line. We will shade because it's greater than to the right, and this is dotted. So we have a dotted line at x equals 2, and we will shade to the right. What about graphing a nonlinear inequality in 2 variables? And so we're looking at x squared plus y squared is less than or equal to 9. Do you guys recognize what this equation is? This is the equation of a circle. As a reminder, that's x minus h squared plus y minus k squared equals r squared. And so my center is at 0, 0, and my radius is 3. This will have a solid outline, and I will be shading inside because it's less than it. So we have a center at 0, 0, and we need to go out 3 units in all directions. This is going to be a solid circle. And we will be shading inside. And so the solution set of a system of linear inequalities in 2 variables is the set of all ordered pairs that satisfy each inequality in the system. Once both inequalities are graphed, you must find the region, if there is one, that is common to every graph in the system, or the intersection. So let's go ahead and try this with x minus y is less than 1, and 2x plus 3y is greater than or equal to 12. So I'm still going to label my equation so I don't get confused. And I'm going to leave equation 1 in purple and equation 2 in pink so we can distinguish it on the graph. So x minus y is less than 1. Let's go ahead and solve this for y. Put it in slope-intercept form. That's negative y is less than negative x plus 1. And so dividing by negative 1, we have y is now greater than x minus 1. And so my y-intercept is at 0, negative 1. My slope is 1. So we go up 1 over 1, or down 1 to the left 1. This is a dotted line. And we will shade above. So let's go ahead and plot the first one. 0, negative 1, and we have a slope of 1. We have a dotted line. And we're just going to use some arrows to indicate where we'll shade so we can figure out the intersection. And so in this case, we're going to shade above. So just to let us know, and then we'll be looking for their common place. Let's do the same thing for example number 2. We've got 2x plus 3y is greater than or equal to 12. So we need to solve for y. We've got 3y is greater than or equal to negative 2x plus 12, or y is greater than or equal to negative 2/3 x plus 4. And so my y-intercept is at 0, 4. My slope is negative 2/3. So we're going down 2 and to the right 3, or up 2 and to the left 3. This is a solid line, and we will be shading above. So at 0, 4, we go down 2 and to the right 3. Or we can go up 2 and to the left 3. This is a solid line. And we're shading above. And so we want to see where my arrows are all pointing. And so this top triangle, where they're both pointing into, is my solution. So go ahead and pause the video and try example number 6 on your own. So first things first, we're going to label our equation. So equation 1, we have y is greater than or equal to x squared minus 4. And so this is a parabola. That's been shifted 4 units down. It will be solid, and we will shade above. So 0, negative 4. We have 1, negative 3, and negative 1, negative 3. We got 2, 0, and negative 2, 0. And you get the idea here. We have a solid line, and we're going to shade above it. So go ahead and draw your little arrows pointing in. And now we want to look at equation number 2. X minus y is greater than or equal to 2. Let's go ahead and solve for y. We have negative y is greater than or equal to negative x plus 2. Or y is now less than or equal to x minus 2. And so my y-intercept is at 0, negative 2. My slope is 1. So up 1 over 1, or down 1 to the left 1. This is a solid line, and you're shading below. So we got a solid line. And we're shading below. And so again, we want to see where the arrows are pointing, and it's at the bottom of the parabola underneath the line, this little sliver. And that is your solution set. And for the last one, now we've got 3 equations, but it works exactly the same way. We've got equation 1, equation 2, and equation 3. So let's look at equation 1 first. X minus y is less than 2. Solving for y again. Negative y is less than negative x plus 2. But that's y is greater than x minus 2. So my y-intercept is at 0, negative 2. My slope is 1. So up 1 over 1. Or down 1 to the left 1. This is a dotted line, and we will shade above. So let's go ahead and plot this. This is dotted. And we will shade above. Equation number 2 is -2 is less than or equal to x, which is less than 4. So this is like two equations in disguise. We have that x is greater than or equal to -2, and we have that x is less than 4. So these are both vertical lines. So x is greater than or equal to -2 will give me a solid line, and it will be shaded to the right. And x is less than 4 is dotted and will be shaded to the left. So x with -2 and x with 4. And the last one, y is less than 3. Well, that's horizontal. That's going to be dotted. And it will be shaded below. And so now we need to see where all the arrows point in towards. So it'll be in between my pink lines and below my orange line and above my purple line. And so this little triangular region would be my solution set.